Dear student, I am Kamini Pawar, Assistant Professor from Department of Chemistry, Sangukana Thakur, ACS College, New Panvel. Today we are going to study about one of the very important topic of physical chemistry, and that is thermodynamics. These are our today's content, and that is the introduction of thermodynamics. In that we will see the definition of thermodynamics and the different example related to it. Then the thermodynamic terms, types of systems, extensive and intensive properties, and lastly the laws of thermodynamics. Students, the thermodynamics is the study related to the heat, work, temperature and energy. The word thermodynamics basically implies a flow of heat, and as per the definition of thermodynamics, it is a branch of physical chemistry that deals with the study of interconversion of heat into the different form of energy. Now student, it means the heat energy can get converted into the different form. Means the heat energy get converted into the chemical energy, electrical energy, mechanical energy and so on. Okay, so this is the definition of thermodynamics. Now see student, suppose a thermodynamic study which is related to the chemical processes, then that came in a category of chemical thermodynamics. Okay, now see, thermodynamics is one of the important branch of physical chemistry, and these having some objectives, and these are to improve the efficiency of the process for the transformation between the energy and work, to study the energy conversion in a different forms, and to study the entropy of a system. Then you can see the basic terms which are involved in the thermodynamics. And student, thermodynamics, in order to study the different concept in detail in thermodynamics, we need to understand some basic terms which are involved in it. According to that, we have the system, surrounding and boundary. These are the different terms which are there in the thermodynamics. So let's see first of all the system. You can see in a figure, this is a portion, the whole portion which is a greenish, that is a system, a thermodynamic system. So a thermodynamic system, it is a part of universe which is under the thermodynamic study. Okay, now the surrounding is this, that means this whole portion. Okay, so the everything in the universe which is not a part of system, that is called as a surrounding. And you can see the universe, basically the system, surrounding and boundary all together is known as the universe. Okay, so this is that you can say, so this is the terms as the system, surrounding and boundary. So as per the definition of boundary is anything that separates the system, and a surrounding, that is known as a boundary. Means a system which is under the thermodynamic study, boundary which is in between the system and the surrounding, and the universe is all together, that is system, surrounding and boundary all together form the universe. Okay, now student, the boundary are of different types, as a rigid wall, permeable wall, impermeable wall, then dithermal wall and adiabatic wall. Now rigid wall is a boundary which is having a fixed position and shape. The impermeable wall is a wall which do not allow the transfer of matter. Then permeable wall which allow the transfer of matter as well as the energy. Dithermal wall which is a good conductor of heat. You can see in this particular figure, this is a figure of dithermal wall where the transfer of heat can easily takes place from system to surrounding and surrounding to system. So dithermal wall is a wall which transfer the heat from system to surrounding and surrounding to system. Then we have a adiabatic wall. The adiabatic wall which basically do not allow the transfer of heat in the system. Okay, that means a adiabatic wall where no transfer of heat takes place inside a system. This is known as a adiabatic. So types of system. Basically the system get classified into three category: the open system, closed system, and isolated system. So open system you can see in a figure. This is the open system. The open system in which the transfer of both the energy and matter can take place. So you can see in a figure, this is simply a test tube, and in that test tube I kept a hot water, and that hot water, so here the heat and the mass both can get transferred easily. So this is known as the open system. So open system is a system in which both the energy and matter can transfer, and that is known as the open system. Then we have a next thing, that is a closed system. The closed system in which only transfer of energy takes place, and that is, you can see in a figure, this is a hot water which we kept in the sealed metallic container, and this hot water, after some time you can see that hot water get converted into the normal water. That means the transfer of heat takes place. So closed system in which only the transfer of energy or transfer of heat takes place, that is known as a closed system. Then we have lastly the isolated system. The isolated system in which neither exchange of energy nor matter, that is the isolated system. That means, student, you can see this is a thermos where we kept a boiling water, and which is sealed or closed from the top. So after some time also, if you gonna see the water, then the water remains hot as it is in the thermos, because the system which do not allow the transfer of matter as well as energy. So volume of water is same, and also the energy, which is that we can say the energy remains as it is. So such a system where neither exchange of energy nor matter is known as the isolated system. Okay. Then we have, students, the properties. The thermodynamic property basically get classified into the two types: the extensive property and the intensive property. The extensive property means the property which depends on the mass or the amount of substance. That is known as the extensive property. Example are of the volume, energy, mass, free energy, and so on. And now the next, which is the intensive property. The intensive property do not depends on the mass or the amount of substance. That is known as the intensive property. Example are the density, surface tension, pressure, temperature, etc. You can see in a figure, this is a boiling water, and boiling water, suppose I take this is a boiling point. The example, suppose I take of extensive property of boiling point. Then suppose I took 100 cm cube of water, then it's showing me a boiling point as 100 degrees Celsius. Then similarly, for 1 liter of water also, it's showing me the boiling point as 100 degrees Celsius. That means the boiling point is a property which do not depends on the amount of substance. Okay, so this is the extensive property. And suppose similarly I consider the volume, then definitely the volume of 100 cm cube of water is less to that of the 1 liter of water, because volume then we can consider as volume, which is the intensive property. So basically the property which depends on mass, that is a extensive property, and property which independent on mass, that is the intensive property. Okay, then we have the last thing, that is the laws of thermodynamics. Now students, here we are going to study about only the statements of laws of thermodynamics, as there are 4 different laws of thermodynamics, such as a zeroth law, first law, second law, and third law. Okay, so zeroth law of thermodynamics, let's see the statement of zeroth law of thermodynamics. If 3 body, we consider a 3 body like A, B, C. You can see in this particular figure, these are the 3 bodies A, B, C. And suppose the 2 bodies such as A and B are in a thermal equilibrium with third body C, then the body A, B are also in a thermal equilibrium with each other. That means A body is in equilibrium with C, B body is in equilibrium with C, then according to zeroth law of thermodynamics, the body A and B are also in a equilibrium with each other. This is a statement of zeroth law of thermodynamics. Then we have a first law of thermodynamics. The first law of thermodynamics state that energy can neither be created nor be destroyed. It just get converted into one form to the another form. Okay, that means student, the total energy of universe which remains the constant, and you can see this is a mathematical statement of first law of thermodynamics. Delta E is equal to Q plus W, where delta E is a change in a internal energy, and that is given as E2 minus E1, where E2 is the internal energy at final state and E1 is the internal energy at initial state. That means difference between the two internal energy at final state and at initial state is given by the letter delta E, a symbol delta E, and delta E is equal to Q plus W, where Q, which the Q is nothing but the heat, and W, which is a work done by the system. And this is a mathematical statement of the first law of thermodynamics. Then we have a second law of thermodynamics, that is, it states that in all the spontaneous processes the entropy of a universe increases. And lastly we have a third law of thermodynamics, and that states that the value of entropy of a completely pure crystalline substance is at zero at absolute temperature. That means you can see in a figure, decrease in a temperature, the decrease in a kinetic energy, more decrease in a temperature, more decrease in a kinetic energy, and at once the point reaches where a zero, the absolute zero temperature is there, that time the kinetic energy is also absolute zero. So it means for pure crystalline substance at absolute zero entropy, the temperature is absolute zero. Okay, and thank you so much.